Hi, it's Bentley's mom. Okay, today we're doing chapter 12, lesson 3, box and whiskers plots, or box plot. A lot of times they're referred to as box and whiskers because it looks like a box with like whiskers coming out of it. So the first thing you're going to do always with these is you're going to put your data in order. So I'm doing example 1 on page 880. What I did was I put the data in order first, okay, and make sure you circle off so you know that you don't accidentally count something twice or miss something. So when it's in order, you look at the data, I can see it goes from 19 to 40. So that's about 20, the range is about 21. So I'm going to choose to go by 5s. You could probably choose to go by 2s. So you have to decide your interval. So I'm going to draw, you always draw your number line first. So I'm going to draw the number line. Okay, and then I'm just going to start with 10 and go by 5. So I just go a little bit before the data. So 10, 15, 20, 25, 30, 35, 40, 45. Okay, so whatever your interval is, it just needs to stay consistent. If you go by 5s, you have to go by 5s the whole time. If you go by 2s, you have to go by 2s the whole time. Okay, so what we're going to do first is we're going to find the median. Okay, that's the main. So what this basically shows, what a box and whisker shows, it shows the median and the quartiles. So what we're going to do is we're going to cut the data in half, okay? And then we're going to take the lower half and cut the data in half, and that's what gives us quartile 1. Then we're going to take the upper half and cut it in half again. That's what gives us our quartile 3. So the quartiles just split your data equally into 4 pieces, like quarters. Like there's 4 quarters in a dollar. So it's going to be like 25% of the data, 25% of the data, 25, etc. Okay, so we're first going to find the median. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the median is 25. Okay, then I'm just going to put a dot. So draw your dots above your number line. So I'm going to draw the median at 25, not on it, because then the box and whiskers will run into your numbers. You want to draw it above. Okay, now I'm going to find quartile 1. Okay, so what I'm going to do is find the median again, essentially, but from here to here, from these two. Okay, so we're going to go, we're not going to include this. We're going to go 1, 2, 1, 2, and quartile 1 is at 22. So we're going to go to 22, which is about right here, and I'm going to make a dot. Okay, and that's my Q1. So that's 22. Okay, now we're going to do the same thing to the upper half of the data. So we're going to find the median of the upper half, which is quartile 3. So, or the middle. 1, 2, 3, 1, 2, 3. So it's going to be 34. Okay, so this is Q1. This is the median, and this is Q3, and we're going to plot that. And 34 is about right here. Okay, now what we're going to do is we're going to draw the box, the rectangle around Q1 and Q3 like this. So you're going to draw a box, and those are the endpoints of the box. Okay, and then the median is the center of all the data. So we're going to draw a line through that really thick. So that big line right there, that's our median. Okay, so you should have a box, and then you should have a line through the box, which is your median. Okay, now we're going to do what are called the whiskers. Okay, and those are called, they say the upper and outer extremes. So we're going to find the extremes. Okay, in higher level math, the extremes are called the minimum and the maximum. So basically we're going to find the minimum or the smallest piece of data and then the maximum piece of data. So if it's in order, the smallest or the minimum or our lower extreme would be, Bentley, what's the lower extreme?
19.
Yep, and then what's the maximum or upper extreme?
40.
40. Okay, and on the calculator, they're referred to as minimum and maximum, and in higher level math, that's what they'll be called. Okay, but lower and upper extremes are the same thing. So minimum's 19, so we're going to go right here and we're going to draw a dot. Okay, and then we're going to go to the maximum, 40, and we're going to draw a dot here. Okay, and then I like to draw all the dots, try to keep them in a nice pretty line. That'll make your graph a little better. Then you just connect the whisker like this. So it kind of looks like I don't know, a cat with whiskers or kind of a robot with whiskers coming out. That's why it's called a box and whisker. So all these points are the minimum. Here's the minimum. Okay, here's Q1. This is the median. Okay, here's Q3, and here's your maximum point. Okay, and that's a box and whiskers. So now let's answer some questions. Let's look at example 2. It says, half of the drivers were driving faster than what speed? So half of the drivers are on one side, the other half are on the other side of the median. So half the drivers are over here, half the drivers are over here. So what they're really asking you for is, what is the median? So for number 2, half the drivers are driving more than 25 miles per hour, and then the other half are driving less than 25 miles per hour. And then number 3, it says, what does a box length tell us about the data? So on this side, if you go from the minimum to the median, everything's from the median. Do you see how it's all squished like this? It's all squished. So basically, the data is more concentrated here. So you can say something like, the first half of the data, you could say, is concentrated or is really close together, is concentrated, where the last half of the data, do you see how it's a lot longer? The box is longer, and then the maximum point is way longer. So you can say the last half is stretched out. You can say anything along those lines. Sorry, my handwriting's not that great. Okay. So then the next one, under 3B, it says, what percent were driving faster than 34 miles per hour? So Bentley, let's see if you can figure this out. So you go to 34. It's asking what percent of the data was driving more than this? What percent is that? Okay, so remember, what did this cut the data into?
Right, the quartile 3.
Quartiles. So it's 25% of the data is from here to here. The next 25% is from here to here. The next 25% is from here to here. So the
25%.
last 25, yep. So it's basically saying from quartile 3, this last quartile, this is actually Q4. So this is the last 25% of your data. So it goes 25% of your data, the next 25, the next 25, the next 25. So for 3A, you would just say, or 3B, you would say the last 25% of the data. Okay, and now example 4 is the last one before you start your homework. Okay, example 4 says, it gives you a box plot. So let me draw it. This is on your paper. Okay, and they go 45 to 110. So it's actually, I'll scoot this over. So we have 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110. Okay, so there's our line, and then they give this to you. It looks like this is a little bit above 55, so maybe 56. And then there's a dot at 65. And then there's a dot at between 70 and 75. And 80. And 90. Okay, so this is what it looks like. Here's our box. And the Q1 and Q3. And do you remember what this is, Bentley, this middle one?
The median.
That's called the median. Okay, this one is Q1. This one is Q3. And then those are your upper and lower extremes. Your lower extremes here, it's also called the minimum. Your upper extreme is here, it's called the maximum. Okay, so that's what all those points are saying. Okay, so it says the box plot below shows the daily attendance at a fitness club. Find the median and the measures of variability. Then describe the data. So the median, you just have to look at it and know that it's the middle line. And you know, if they don't give us the data, it's in between 70 and 75. So I'm going to write 72.5. Okay, so just somewhere close to that is good. The next one is quartile 1. So I just look for this line right here. It looks like it's right at 65. I'm going to find quartile 3. What does quartile 3 look? Where does it look like, Bentley?
Around the 80.
Yeah, 80. Okay, and then we have, let's find our range, the range of data. This actually, there's an outlier here. I just noticed that's all the way at 110. There's a dot right here. So technically, that's not the maximum, sorry. So it depends. If the outlier is not, if the outlier is included, your maximum point would be 110. And the whisker actually would go all the way out to that. If your outlier is excluded, which, depending on what you're trying to do with your data, then this would be the max point. But technically, when you're including this outlier, that would be the maximum point.
I have a question.
So, yeah.
So since there's only 5 numbers on the number line, and 4 of those 5 are within a 40 range, but then 110, would that be an outlier because
yes, absolutely.
there's only 4 of the normal ones?
Well, it's way out there. Okay. So again, you would have to take your interquartile range and multiply it by 1.5 to find exactly if that's an outlier or not. For this level, you should just, if there's a point that's kind of nowhere near the rest of the data set, you're going to refer to that as an outlier. So we're going to call that an outlier. So our range is you have to take the biggest piece, the biggest number, which is 110, and subtract the smallest, which looks like about 56. So I'm going to do 110 minus 56. So the range
It's not an outlier.
is 54.
Mom, I don't think it's an outlier.
Okay, so we'll go over that in just a second. So I'm just going by your book, okay? So we haven't done the actual calculation, but the way they gave us, so here's the situation. They gave us this, and they did not include this, okay, in the graph as a whisker. So because they stopped the whisker here, then that's telling us they're considering this an outlier. So if it's not in the graph, we're going to call that an outlier. Now, again, technically in real life, if you were doing a study, you can drop off outliers during certain types of statistics, and that's the way when you look at data and you're trying to present it. You can also pick the statistics that make your data look the better. So or look however you want it to make it look. You still have to do the math right, but if you're going to choose to not include that because it's throwing off your data, that's what they did in this picture. Now, if they drew the whisker all the way here, then we would be including that in the data. And again, this was given to you in the problem. So, okay, so our range is 54, and then the interquartile range, do you guys remember how to find that? You take Q3, which is 80, and you subtract out Q1. So our interquartile range is 15, 80 minus 65.
And then times it by 1.5.
Yeah, to find the outlier. Like, so if we were doing this, if we just had the list of data and they didn't give this to us and we wanted to know if this was an outlier or not, we would take this and multiply it by 1.5 and see from quartile 3 if that was that many spaces
So it wouldn't
beyond.
it wouldn't be an outlier.
But they gave this to us, and so in the drawing they gave it to us as an outlier. So we have to follow what they gave us in the problem. Okay, so the outlier here, you can, there's a little dot way off in 110 would be 110. Okay, and then that's what they basically. This is what's describing your data. Okay, so you're describing, how far the smallest and biggest ones are. You're cutting your data into 4 pieces. The middle of your data is 72.5. So you can kind of take all of these statistics we took and write it out in words. Like, the middle number of the data or the first 50%, go up to 72.5, and then the last 50% or above that, something like that. Okay?
Quick question.
Yes.
So if you were to calculate what the interquartile range was for the thing,
So we can calculate that. Let's do 50.
It would be 22.5. So technically, it is under 22.5 from 90 to 110. But would
That's
it measure from the closest spot to it or from the median? Like, so do you measure that 22.5 off of 90 because it's closest
No,
to
off
it?
of quartile 3.
Okay, so you don't measure it off of 90.
No. Well, usually you do it off of quartile 3.
Okay, so it would be an outlier then.
Yeah, so it would be an outlier because 80 plus 22.5 is
Be 100.
less than, yeah. And that's technically how you do it. This is not something, you're required to know at this level of math, but that's how you would technically find an outlier. Okay, that's it. Bye.
Bye.